So this is the basic anatomy of mechanics. So if you study the mechanics, you will find different type of categorization of mechanics. So this is mechanics, basic and the oldest, one of the oldest branch of physics. Mechanics, it is divided in these parts. That is relativistic mechanics. Relativistic mechanics is the study of motion at relativistic speed that you will study in advanced physics. At relativistic speed, that is speed close to light, and it is explained and studied under relativity theory proposed by Albert Einstein. So that is called relativistic mechanics under very high speed, very close to speed of light. The motion is studied under this branch of mechanics. Second is quantum mechanics. Quantum mechanics is also very advanced branch of physics that is studied under quantum theory. So under quantum physics, we study the motion of very small particles like electrons, neutrons, quarks, etc. So these are about study of very small particles. Next is deformable body mechanics. Deformable body, we know in general all bodies are deformable. So that branch of physics which deals with study of stresses, study of deformation. So under this deformable body mechanics, we study the forces and behavior of body under various internal stresses, strains, Young's modulus, etc. So one of the branch of mechanical engineering that is called strength of material. So strength of material, whole branch of mechanical engineering is studied under deformable body mechanics. That is study of beams, study of various parts of machines which undergoes a deformation, change in their dimensions under application of forces. So that is the deformable body mechanics. Next is fluid mechanics. Fluid mechanics we will study and discuss basic concepts of fluid mechanics. In this fluid mechanics we study the motion of fluids. Different type of motion of fluids exist, that is laminar flow, turbulent flow, and other types of behavior of fluid, different types of motions of fluid, and they all are studied under fluid mechanics. That is the separate branch of mechanics. Next is rigid body mechanics. Rigid body, we will after some time we will discuss what is rigid body and what is the theory of continuum physics. Rigid body mechanics is a separate branch of mechanics which is studied under continuum physics. Continuum physics means a physics of materials, physics of bodies having continuous mass, that is real bodies. So that study of real body is discussed and studied under rigid body mechanics. So rigid body mechanics is divided in statics and dynamics, two parts. Under statics, as we have discussed, we study forces acting on the body or a system of bodies when the system or body is under equilibrium. Either it is stationary or it is moving with constant motion. That is called equilibrium. Stationary state or a constant motion state. Constant translatory motion or constant rotational motion. This state of any system or body is called stationary state or equilibrium state in physics. So that study of forces under equilibrium condition is carried out under this statics. Second branch is dynamics. As its name suggests, body is under motion. Body is under motion. Body is changing its position. It is under acceleration, changing its motion. It is not in equilibrium. Forces are acting on the body and body is changing its motion. That study is carried out under dynamics. Dynamics is further divided in two parts. First part is kinematics. Kinematics both are study of motion. There is slight difference between these two parts of dynamics. In kinematics, motion of body is studied, whereas the mass and forces acting on the body are not considered. Motion of body is studied, but mass of body and forces acting on body are not considered. We only study the position, the velocity, the acceleration of body, ignoring its mass and forces acting on the body. For example, V is equal to U plus AT. Velocity is equal to initial velocity, final velocity is equal to initial velocity plus acceleration into time period. In this equation, motion of body is studied. Body is undergoing an acceleration. We are finding velocity after time t. But mass of body and forces acting on body is not considered, is not required at all. Whereas forces are acting on the body because body is accelerating with acceleration A. That means forces are acting, but it is not necessary to consider the forces. Body will have some mass, definitely body will have some mass, but mass of body is not considered at all. It is not required at all. So in kinematics, we study the motion, position of bodies without considering their mass and forces acting on the body. Whereas in second branch, that is called kinetics. This is kinematics and this is kinetics. In this branch, we study the motion of bodies with consideration of forces acting on it and mass of the body also. So that study of motion with force and mass is carried out under kinetics. So the famous formula of Newton's law of motion, F is equal to m into A. In this, force is considered, mass is considered, and acceleration of body is considered. So this formula, where we apply this formula, then we are studying the motion of body under kinetics with consideration of forces and mass of body. So we will have a brief discussion about force. In basic language, basic terminology, force is nothing but it is a push or pull. It is a push or pull applied from one system to other system. Again I am repeating, in basic language, force is simply a push or pull applied from one system to other system. For example, this is a block. You can say this is a system of mass m. This is one system. This is another system. It is a spring. This is a spring. Suppose it is in compression state. So this spring is exerting a force F. spring is a one system. This is system number 1. This is system number 2. You can say system spring. This system is exerting a force, that is a push or pull, on this system number 2, that is a block of mass m. This force is exerted by spring on mass. This is a push. This force is just pushing the block. The next important thing which you must always remember, that forces are always in couple. They always exist in paired form. You will never find a single force. You will never find a single force. It always exists in paired form. By the third law of Newton, we know there is action and there is reaction force. So they are always paired. So if spring is applied, if you make separate diagram M, and this is spring. This spring is applying a force F on this block. This F force is applied by spring on block M in this direction. As a reaction force, this block will exert a force F on spring also. So both system, that is spring as well as block, will experience a force, but both these forces will be exactly opposite to each other because they are action and reaction. There are always two forces. Never it will exist in a single form. And another important thing, both these forces never applied on same object or same system. There are two forces. One is applied on mass m and second is applied on spring. Both F forces are equal and opposite to each other. Both these forces are not applied on mass m, or they are not applied on spring. F force is being applied by spring on mass m towards this direction. In the reaction, this mass is applying F force in opposite direction on this spring. So both spring and mass are experiencing force F in exactly opposite direction. So this is the basic definition of force. It took more than thousands of years to understand the concept of forces. If we go in the history, then you will see initial explanation of forces or initial observations comprising the phenomena resulting from forces were carried out by Aristotle. Aristotle initially gave very simple law of motion to understand and explain the forces. He said that a block, it is a wooden block, let it is a wooden block and it is plane surface. So Aristotle observed by experimental method that this wooden block will keep the motion in this direction with any velocity v until a force is applied on this block. So he said that to maintain an object in constant motion, we have to apply a force constantly on that object. Only then the object can maintain a constant motion. That was the law proposed by Aristotle. That is, to maintain the constant motion by an object, we have to apply a constant force on the object. When we stop applying this force, this wooden block will stop after some movement, after some displacement. After stopping application of this force, this wooden block will stop after some displacement. Hence, we have to apply a constant force to maintain its constant motion. That law was proposed by Aristotle. So Aristotle basically divided law of motion in two broad categories. First, law of motion on earth, and second, law of motion on heaven. All those planets and stars, they were called heavenly bodies. So he said that law of motion for planets and stars are different than law of motion of objects on earth. Heavenly body have different law of motion, and bodies moving on earth have different law of motion. That was the theory proposed by Aristotle. Because heavenly body, objects, planets, they continue to move in their orbits, in their circular paths, without application of any force, any known force, because at that time the understanding of force was very limited. So it was said that these stars and planets are not experiencing any force, still they are moving. How can they move without application of force? So Aristotle said that heavenly body have different law of motion. Without application of force they can move. But bodies on earth, they have different law of motion. To maintain their motion, we have to continuously apply a force. When we will stop applying force on an object moving on the surface, this object will stop after moving some distance, after covering some distance. So that was the initial explanation of motion and forces proposed by Aristotle. Now we know that to maintain constant motion, we need not to apply any force. We have to apply a force to accelerate the body. But to maintain constant motion, we need not to apply any force. That we know today. But at that time, such theories were not proposed. So Aristotle actually missed the phenomena of friction force. That's why he said to maintain the constant motion of this object, we have to apply force. Otherwise, when we stop applying force, it will stop. Why this object is stopping? We know today that it is stopping because of friction. But Aristotle at that time, friction concept was not in existence. After the concept of friction came, then this phenomena can easily be explained, that we need not to apply constant force for a block moving in a frictionless surface. It will continue its motion with constant velocity on a frictionless surface without application of any force. So that friction concept was missed by Aristotle. But even though this law proposed by Aristotle is not correct today, but it gave basic foundation of mechanics, of law motion, to understand the motion and to develop the motion, develop the theories of motion. Though the concept is wrong today, but this concept laid the foundation of theories of motion and forces by next generation physicists. So this was the understanding of force and motion at the time of Aristotle. So these principles were changed, proved wrong by next generation physicists. Some of them were the Galileo and Kepler. Galileo proved that law of motion are same for bodies on earth as well as in heaven, that is planetary bodies. Galileo proved that because of friction on earth between different surfaces, body actually stops after some distance when we stops applying force on the body. So we need not to apply continuous force to maintain a constant motion on earth. If there is no friction between two surfaces, then body will move with constant velocity. That was said by Galileo. This experiment, if there is no friction, then it will move with constant velocity without force. That was proposed by Galileo against the theory of Aristotle. So Galileo changed slightly the laws of motion proposed by Aristotle and concept of force to concept of motion of heavenly bodies and bodies on earth. Later on, the concept of force was more precisely explained by Sir Isaac Newton. Concept of force was also quantified. It was quantified by formula F is equal to m into a. That is a famous formula we all know. Isaac Newton defined the force properly and quantified the force with the help of this formula. After this proper definition and quantification of force, understanding of motion changed forever. So that is how the concept of force was initially given by Aristotle to explain the motion, and later on modified by Galileo by introducing concept of friction and modifying the laws of motion proposed by Aristotle, and later on the same concept of force was properly defined and quantified by Sir Isaac Newton. Another definition of force, you can say a force is a cause that tend to alter the state of equilibrium or state of constant motion of a body. It is a cause that tend to alter, that means that try to change the equilibrium state of a body or the constant motion state of a body. So we know that most of the things in universe, almost all things in the universe, they try to achieve a preferred configuration. When forces are applied on the object, when any object or system undergoes some types of forces, then system naturally try to achieve a preferred configuration under application of different forces. Preferred configuration means a natural tendency to change the state of a particle or system or mass. It's a natural tendency to change its state of motion, state of equilibrium from one state to other state. That is called change in configuration. So every system prefer to change its configuration when a force is applied on this system. So in universe, all planets, stars and galaxies are moving. They are changing their configuration. They are going to achieve the preferred configuration. Why? Because they are experiencing different types of forces, gravitational forces. All galaxies, stars, planets, etc., satellites, they are experiencing different type of forces, gravitational forces. That's why they are moving and trying to achieve a preferred configuration. That is all another consequence of force. That is, body will try to achieve a preferred configuration when a force is applied. For example, this is a person. This is a person standing on the ground. He is standing on the ground. When a force is applied on this person, before application of force, this person is just standing on the ground in a particular configuration, in a particular state. He is just standing. When a force is applied, this person, we can assume this person as a system. This person will try to achieve a preferred configuration. So it will change its state, it will change its motion so that the effect of this force is nullified. That is the change in configuration. So when a force is applied, so if there is sufficient friction force between person's foot and ground, then he can resist this force. Person is resisting the force with the help of friction. His configuration is not changing, his state is same, but you can see he can resist the force. This friction force starts to exist by the time this external force is applied on this person. When this force was not being applied, there was no friction force. When this force is being applied, this friction starts to exist, and this friction is opposing this force. So this friction force is acting on this direction, equal to F. Even though person's configuration is not changing, but a force has generated. That is called friction force. When the external force is applied. Suppose this force is again increased and this friction force is not able to balance this external force, overcome this external force, then this person will start to slip on the ground. This person will start to slip on the ground, and if the friction force is small f and mass of the person is m, then the person will move with acceleration is equal to f minus small f by m. That is simple Newton's second law, we will discuss detail. So the acceleration of person in this direction is capital F minus f, small f force, that is this force minus friction force by m. So person starts to change its position and start to accelerate. That means person starts to change its configuration when the force is applied. So like this person, every object in this universe tries to achieve preferred configuration. Preferred configuration means preferred motion. This person is moving in this direction, he will not move in this direction. In this direction he will not move. Preferred motion is this direction. Why? It is based on this force, direction of this force. So person starts to move in preferred configuration when this force is applied. So that is the law for every object on this universe. Every object starts to achieve its preferred configuration when an external force is applied. That is the reason things start to accelerate, things start to move in a particular preferred direction based on the direction and amount of force. We know we cannot see the force. We cannot see the force, it is invisible. Forces are invisible. So by their effect, by the consequences, we can guess, we can understand that particular object is undergoing a force, even though it is invisible. So these were the basic definitions of force. Now, quantification of force. That means how fast a body will move or accelerate, or how fast a body will change its configuration, how fast a body will try to achieve its preferred configuration. That quantification of force is done by Sir Isaac Newton and we know the second law of Newton, F is equal to m into A. This second law of Newton, it quantifies the amount of force applied by one system to other system. This is the quantification of force. If F is the resultant force, this is the resultant force. For a point mass, Newton's law of motion are given for a point mass, that we will discuss after some time. What is the difference between point mass and a real rigid body? So laws are almost same, but with slight difference. So Newton's law of motion are given for point mass. They have been modeled. Newton had modeled his motion, laws of motion for a point mass. But we know in real life, we don't deal with point masses. We deal with real mass, real objects. So we have to slightly modify the Newton's law of motion. Even though they are Newton's law of motion, but in modified form for rigid body, they are called Euler's law of motion, that we have discussed earlier also. Euler's law of motion are for rigid bodies, that is studied under continuum physics, that is continuous mass physics. So Newton's law of motion are for point mass. If this is a point having mass m and different forces F1, F2, F3, F1, F2, F3 are acting on this, and resultant forces F this, then we can say F is equal to m into A, or A acceleration is equal to resultant force by mass. So this second law of motion, Newton's second law, quantifies the force. It quantifies the force. How fast, how quick the object will accelerate, it will move. So that is the law quantifying the force. Now we will discuss how to measure the force, because we know force is invisible. We cannot see the force. Then how to detect it? How to measure this? So there are some basic techniques to detect and measure the force. The first is, by spring mass system. So with the help of spring scales, if a force is applied on this spring, it is deformed and this block comes here. This is distance x. This is distance x. Then we know, and the spring constant is k. K is the spring constant. Then we know F is equal to k into x. So by measuring the displacement of spring when a force is applied on it, and we know the spring constant k, we can find the force applied on spring scale. This is a spring scale. So this distance x is directly calibrated in terms of force, because here you see force is proportional to distance compressed or elongated for the spring. So this distance is proportional to the force. So on this scale, these scales can be marked on this spring system, and these scales, which are nothing but displacement of spring, can directly be calibrated in terms of force. 1 Newton, 2 Newton, 3 Newton, etc. So with the help of spring scale, you can find the amount of force being applied at one end of the spring. So this is one very simple and basic method to detect the force and measure the amount of force. So that was very simple method. In industries, we use load cells, that is load transducers, to measure and detect the force. Load cells are used to measure very heavy loads, heavy force, high quantity force. So we will just discuss the construction of load cell for your basic understanding. Even though you don't need to know at this stage, you will study all these things in engineering. So load cell, you can assume load cell, which is used to measure and detect the load, heavy loads, is a cylindrical object, cylindrical, hollow, stainless steel or any other material object. So it's a hollow cylinder. In this cylinder, they use strain gauges. Strain gauge are nothing but these are the wires of certain materials. So when a load is applied, on this hollow cylinder, then these strain gauges, that is wires attached on this cylinder, will compress. Their length will change, delta L. Length of these wires, which are called strain gauges, will change. To detect the change in length, we measure the resistance, electrical resistance of this wire. We know electrical resistance of wire is proportional to L, that is length of wire. When length of wire changes, resistance is also changed. So what is the sequence of event? First of all, a load is applied on this load cell. This is called load cell. Then second step, when the load will be applied, its dimension will change. Whole length of this load cell will change. With change in length, the length of these strain gauges, wires attached on this load cell, will also change. Change in length will cause to change the resistance. So we will measure the resistance, change in resistance of these wires with the help of a circuit. By measuring the change of resistance, third step, we will find change in length. Their length is so small, change in length is so small that we cannot directly measure with the help of scale. We are measuring change in resistance with the help of circuit, and that change of resistance is related with change in length. So we can find change in length, because resistance and length are both related. They are just proportional to each other. So we can find change in length by finding change in resistance. And fourth is force applied is proportional to change in length. So another device which is used to study the forces is dashpot. So dashpot is a simple device. Assume it just a cylinder. This is cylinder, and inside this cylinder there is a disc. So the dashpot mechanism consists of a cylinder, a movable disc having a hole, and a liquid. Liquid is filled inside the cylinder. So one end of the external link is connected with the disc, movable disc, and other end with the cylinder. This end is with cylinder and this end with movable disc. Let this end is A and this end is B. So this is the dashpot. Let external force is applied on this end is F, and at this end is F. This is the external force. To balance this external force, damper will apply its own force on both these ends in this direction, opposite to the external force. So at this end, external force is applied in this direction, and damper is applying equal and opposite force at both ends in opposite direction. So this force is given by, applied by damper, is given by neta dl by dt, where L is the distance between end A and B. L is the distance between end A and B. So dl by dt is relative velocity of end A with respect to B or end B with respect to A. So force exerted by damper at its end is proportional to relative velocity of ends of the damper with respect to each other, and this is called rate constant of the dashpot. So these dashpots are used as a dampers to dampen the vibrations. They are used in automobiles. You can see in your bikes, scooters, cars, trucks. These dampers are used. So this dashpot acts as a damper to dampen the vibrations. So this force is proportional to relative velocity of end A with respect to B, and also proportional to rate constant of dashpot. Another device similar to dashpot is used to dampen the vibrations as a damper is called inerter. Inerters are advanced dampers which were first used in McLaren Formula 1 racing cars. They were invented in 1997. So these were called J dampers also. So these J dampers were used in Mercedes, McLaren racing cars, and they were more effective to dampen the vibration as compared with dashpots. So they are simply a flywheel is used. There is a flywheel, and at the center it is connected with two racks in a geared mechanism having rack and pinion. So these two racks move up and down. This is let, this is end A, and let, this is end B. So this is rack and pinion mechanism. This is a flywheel, and this flywheel inertia is used to dampen the vibrations. So the force exerted at the ends by this inerter, suppose an external force F, this is external force at end A and B. So this inerter will exert opposite force at end A and B, F. That is external F force at end A and B. In the reaction, this inerter will exert at A and B force F in opposite directions. So this opposite force exerted by inerter at end A and B is given by mu d square L by dt square, that is second derivative of length. This length is nothing but distance between A and B. So this second derivative of distance between A and B is nothing but acceleration of point A with respect to point B. So force exerted by inerter at its end is proportional to mu into relative acceleration of end with each other, end A with respect to end B or end B with respect to end A. that is acceleration of end A with respect to B, or acceleration of B with respect to end A. This is second derivative of distance. And mu is called inertia constant. Inertia constant of inerter. So inerter, force applied by inerter at its end is proportional to inertia constant of inerter and relative acceleration of end A with respect to end B. So we have discussed basic definitions of force and the basic methods how to detect them and how to quantify them, how to measure them with the help of spring scale, load cell, and other mechanism which exerts forces like dashpot and inerters. Now we will understand and discuss the forces based on modern perspective. Based on modern perspective, we will understand what is the force and how it is classified. So based on modern theories like particle physics, quantum physics, string theories, quantum gravity, there are different type of theories, modern theories. So these theories explains the nature, basic nature of forces, basic classification of forces. So presently, based on modern physics, the forces are broadly classified in 4 categories. So this is basic classification of force based on modern physics. This is force. First is called gravity. We are aware with the gravitational force. Second is electromagnetic force. Electromagnetic force was explained by Maxwell in his equations with the help of his famous equations. Electromagnetic force like electrostatic force between charged particles, magnetic force between two current carrying wires, etc. So this electromagnetic force is the second classification which was explained by Maxwell. Third is called weak nuclear forces. Weak nuclear force, it acts in the very small range, in the range of 10 to power minus 17 meter. 10 to power minus 17 meter, which is 100 times smaller than a size of proton. So it acts in very short range, small range, weak nuclear force, and because of this weak nuclear force, emission of beta, gamma particles, that is radioactive decay of nucleus takes place. This weak nuclear force is created with the help by interaction of boson particles. We will not go in the details. So these boson particles are responsible, their interaction is responsible to create this weak force. So interaction of boson particles like W plus boson, W minus boson, Z0 boson, there are different types of boson are classified. So interaction of these W plus, W minus, W0 based on the type of interaction, a certain type of gamma or beta is emitted from a radioactive nuclides. So that is the reason of weak nuclear force. And last category of force is strong nuclear force. Strong nuclear forces are strongest type of force among all known forces in nature. They are also small range force. They act in very small distance, within very small distance. That is 10 to power minus 15 meter. That is the size of a proton. 10 to power minus 15 meter. So it's a very small range force, and they are created by the interaction of gluons. They are also particles, gluons, you will study in modern physics. So with the help of those, by the interaction of gluons, they act between quarks. Quarks are basic particles which form neutrons, protons, electrons, etc. So with the interaction of this gluons and creating a force between quarks. The force between proton-proton, between neutron-neutron and between neutron-proton is generated as a residual force in a nucleus. So this residual force holds the nucleus tight against repulsive force in protons. So this is the four basic forces found in the nature based on present modern theories like particle physics, quantum physics, string theory and etc. So now presently effort is made to unify these all forces, to give a theory which explains a single theory which explains all the four forces. So up to some extent electromagnetic force and weak nuclear force have been unified with a theory which is called electroweak theory, EWT. This electroweak theory, a single theory, explains both these forces, that is electromagnetic force and weak nuclear force. Theory explaining both these forces is called electroweak theory. Similarly, if attempts are being made to unify these electroweak forces with strong forces, a theory which will unify electroweak force and strong force, this theory will called grand unified theory, GUT, grand unified theory. This theory will explain electroweak forces and strong forces. That means this theory will unify these three forces: electromagnetic force, weak force and strong force. And attempts are being made to quantize the gravitational field. After quantization of gravitational field, a new theory will be used to explain the gravitational field, which will be called quantum gravity, QG. This quantum gravity theory will be used to explain the theory of gravity by quantizing the gravitational field. And after quantizing the gravitational field, a single theory will be used to merge gravitational theory and grand unified theory, that is theory of these three forces. This grand unified theory and theory of gravity will be merged, and this theory will be called theory of everything. The theory of everything will explain all four basic forces. So these are the efforts which are underway to explain and merge and unite all these four basic forces in future. Presently, this gravitational force is also explained with the help of general theory of relativity. We know the gravitational force formula and explanation by Newton's gravitational force theory. Gravitational force is also explained with the help of general theory of relativity. Presently, general theory of relativity assumes that gravitational force exists because of it is actually this theory explains that gravitational force is manifestation of bend in space-time fabric. It is not a force actually. This theory doesn't treat gravity as a force. General theory of relativity says that gravitational force is nothing but it is a manifestation of bend in space-time fabric. So that is another explanation of gravitational theory with the help of general theory of relativity, and in future it will be quantized, it will be merged with theory of everything. As we have discussed the four basic forces of nature based on modern theory. So now we will discuss what is the order of strength of these four basic forces. So the strongest force is strong nuclear forces. Second is electromagnetic force. Third strongest force is weak nuclear force. And the weakest force is gravitational force. So strong nuclear forces are strongest, but they are effective within the range of 10 to power minus 15 meter. Electromagnetic force, they act in infinite range. Weak nuclear force are also small range force, and they are effective in 10 to power minus 17 meter. And gravitational force are weakest force, and they exist in infinite range. So gravity is the weakest force among all these known forces of nature, but gravity plays most important role in shaping the universe, shaping the solar systems, shaping the galaxies, shaping the planets, stars, because these objects in universe contains huge mass. Huge mass is contained in galaxies, in black holes, in neutron stars, in planets, stars, etc. So because of their huge mass, this force predominantly shapes the universe, defines the preferred configuration of the universe, even though it is the weakest force. Because of huge mass available in the universe, this is the most predominant force in the universe, which defines the preferred configuration of everything in the universe: planets, stars, neutron stars, black holes, etc. So we have discussed classification of forces based on modern physics. So these are very basic forces, but we must be familiar with this force. First is gravitational force. So by Newton's law of gravity, we know if these two are point masses of m1 and m2, they attract each other with the gravitational force, and this gravitational force is given by gravitational constant g m1 m2 by r square, where r is the distance between these two point masses. That is the law of gravity, gravitational force, and this gravitational force is always attractive. So as I have told you that there is no single force in the universe, so this gravitational force or any other force, they always exist in paired form. So there are two forces. One is gravitational force on m1 by m2, and second is gravitational force on m2 by m1. They are two forces, but they are being applied at different bodies. They are not being applied on same body. First is this F. This is gravitational force F on m1 having this magnitude exerted by m2 in this direction. Similarly, second force is also F, but in opposite direction. This force is in this direction, in opposite direction, acting on m2, exerted by m1, having magnitude equal to this. So both these forces on m1 and on m2 are acting on opposite directions, equal in magnitude, and one is acting on m1 and other is acting on m2. So these are two forces in paired form, acting on different bodies, having equal magnitude and opposite directions. Second is electrostatic force. We know electrostatic force, if this is point charge q1, this is point charge q2. Let both are positive, for example, having distance r. So by Coulomb's law, force will be 1 by 4 pi epsilon 0 q1 q2 by r square. So this is the magnitude of force. One, if both are positive, we have assumed, so this will be repulsive in nature, and if charges are of opposite sign, then it will be attractive in nature. So this force will act on this, and the same force will act on this. As here also, this F force in this direction, having magnitude this, is acting on Q1 by Q2 in this direction. Similarly, opposite force, that is this force in this direction, is acting on Q2 by exerted by Q1 having magnitude equal to this. So here also forces are in paired form, equal and opposite, and most important thing, they don't exist, they don't exert on same mass or object. They are exerted at different mass. This is exerted at this charge, and this force is being exerted at this charge. Both forces are not exerted on this or this, but they are equal and opposite and in paired form, being exerted at different bodies. Third is magnetic force. Magnetic force, you know, there are two wires having current I1, I2, having distance d. So magnetic force between these wires is given by mu 0 by 2 pi d to I1 to I2. So this is the magnetic force acting on per unit length. This is per unit length. Magnetic force per unit length of these wires is mu 0 I1 I2 by 2 pi d. I1 is current on this wire, I2 is current on this wire, d is the distance between these two parallel wires, and this is the force. So if they are in same direction, both currents are in same direction, then it will be attractive in nature. If currents are in opposite direction, then it will be repulsive nature. So here again, on this wire, this force F is acting, on this wire, this force F is acting. Here also forces are in paired form, but not acting on same body. They will act on different bodies, two different bodies. So we can say at per unit length, this force F is exerted on this wire. It is exerted by this wire on this wire in this direction, having magnitude this. Similarly, on this wire, force F is exerted in this direction by this wire having magnitude this. So there are two forces on different wires in opposite direction of same magnitude. So that is how you will always find forces in paired form, in opposite direction of same magnitude, and acting on different bodies, not on same body. This was magnetic force. You will also see other forces like buoyancy force. If this is a submerged body, let this volume of body is submerged. So this is, let the submerged volume is Vs. So force of buoyancy will be Vs into density of liquid into gravity. That is force of buoyancy. This force of buoyancy will act on submerged part of the body in opposite direction of gravity, and it will act at the center of gravity of the submerged part. As per the Archimedes law, force of buoyancy is weight of displaced water. It is equal to weight of displaced water, which is submerged volume into density of water into gravity. Direction will be upward and its point of application will be center of gravity of the submerged part of the body. This is buoyancy force. Other is hydrostatic force applied by pressure, reaction force applied by walls, floors, friction force. There are other types of forces we will discuss in later chapter. So tension force by cord, applied by cord. So these forces we will discuss in our next topics.